Thank you. Oh, it's on. Oh, wow, it's bright. Hello. So you might have guessed I'm not Australian. So I will be the voice of Australia today. So I'm Stephen.
And I'm Aditya, and you might have guessed I'm not African, but doing a lot of work in Africa.
So we had thought of trying to do this as a bit of a comedy duo, but no, we get no laughs, so we're not going to do that. So I'm going to start, and I'm going to talk a bit about why Australia did some of the work they did using Earth observations for the whole country, and which is essentially the size of a continent. And then I'm going to kind of explain some of the policy side of stuff and some of the financial aspects and the economic aspects. And then I'm going to hand over to Aditya, and he's going to talk about
Digital Earth Africa, how this is leading to some of the work that we're doing there.
Yep. Okay, so please have a seat.
Thank you very much.
Okay, so I'm good on this? Okay. So Geoscience Australia is it's a mixture of a number of organizations. It's essentially very similar to the USGS. They do the geological survey. They also do the national mapping. So they brought together a couple of organizations some years back. And they are the ones who are really looking at the geoscience for the whole of Australia. Now, they wanted to find a way to have a national infrastructure for every government entity to be able to use Earth observations. And so instead of working on an agency-by-agency basis, they brought together the Digital Earth Australia programme. So they had already some money. They had about $7 million per annum, and they put a business case together for a national computing infrastructure that got an additional $13 million per year. So they have that money, about $20 million now, in the government budget for the foreseeable future. So it's a very big program in Australian terms to run Earth observations for the next 5, 10, 15 years. And really what they wanted to do was provide a way to have the coverage of Earth observations for agriculture, for water, for biodiversity, for many different environmental areas for the whole of Australia. So they were working with the NCI, the National Computational Infrastructure, and they've been using the supercomputer in Australia to manage this concept of data cubes. So time-stacked data and looking at the data over a long period of time, essentially from 1987. And they were using the National Computational Infrastructure to do a lot of the work, but they found that it didn't quite have the ease of use or the scalability or the reliability for operational purposes. So they've been moving, they've kept a lot of the research work on the NCI, but they've moved to AWS for the operational stuff. So as you can see here, they're starting to do a lot of stuff in the Amazon Web Services environment. And if you think about when I'm saying operational, they have, for example, the tsunami early warning system is all based on the AWS platform. So everything they do, the development, the production, everything is in AWS. So that's kind of their journey. So when they wanted to do this, they wanted to look at two things. They wanted to look at the whole of government approach I talked about, and anybody in here who's American will understand this, the growth of the economy, so jobs and things related to the economy. So the first part of it was how do we look at natural resources and how do we really make use of the Earth observations, data and information we have? How do we take the Copernicus, so the Sentinel data that's coming from the European Commission programme with the European Space Agency, and how do we take the Landsat data that's coming out of the US, the long-standing program? So they worked on this program on it was originally called the Australian Data Cube, but when you go to get money from the government and you start talking data cubes, people have no idea. So they changed it to Digital Earth Australia so that they could go out and they could ask for more money. So you can see the scale of the area that they're covering And so they needed to have quite a robust program to do that. So this is just showing how they create the data cube. So you can see the pixels here, time stacked. And I think normally there's some sound to this, but Aditya's going to go a bit more into the data cube stuff anyway. But you get an idea that they're doing this coverage for the whole of Australia. Now, the first product they looked at was water observations from space, which is called WOFs. And so they were able to see, they already had some data for Australia, but with the new algorithm from water observations from space, and I'm sorry, you can't really see here, but there were a number of water areas that they hadn't previously been able to recognize. Now, in a continent that has a lot of issues with water, particularly around drought and around dryness, this was really important for them to be able to look at for the whole country. So what actually is showing here there's pockets of water that previously they hadn't identified and now they could. And I think it was something like 80,000 different water areas that they could suddenly identify. So they were able to look at, across the whole continent, where the water was, and also look at where the water naturally pooled, or where the water had been over time, or where new water was coming from. So this was really important in terms of what they're doing. And the water observations from space is actually going to be one of the first products for Digital Earth Africa that Aditya will talk about too. So they were using it really for a policy perspective. So now they could start to look at things like where, if you can see here, in 2002, the first dams that they could record, actually in black is recording rainfall. So they were able to start recording the water for the whole of Australia from this period and feed that into the policy decisions that we're making. So you can see the difference here over a 2.5-year period. The red is where it's empty, and the blue is where there's more water. So they're using this to make these policy decisions. Here, if any of you are familiar with the Ramsar Convention and the Convention on Biological Diversity, this is where they were starting to look at other international policy directives as well. So there's the Kobaru frog, which is a poisonous frog, which is near extinction. And so they need to understand a lot of things about the environment to make sure that this species is saved. Now, I don't know if any of you have heard that there was in terms of malaria and mosquitoes, there was an announcement about a week or two ago about using venom from snakes to kill the mosquitoes. So this is why these poisonous animals actually have a role to play beyond just the ecosystem role they play. There are other things that you can do. So they've been looking at the widest possible issues from an ecosystem environment. And you can see here where you can see in the wetlands where the water is quite high, and then at a certain point they had some fires. And then you can see the rest of it is where there's much more earth than water. And so they have to think about how do they recompense, how do they put the water back into these areas, how do they maintain the biodiversity. So that's the first part, which is all about looking at the environmental topics, what the government's been doing. The second part is then looking at the economic impact. How do they create jobs? What do they do in the economy? So, for example, farming in Australia underpins something like 500,000 jobs. So there's 500,000 people involved in that activity. And so they wanted to be able to use Earth observations to understand things like food security. So for feeding the animals, they wanted to be able to know the biomass. So they made the data, all the data is publicly available, and people started to build apps on top of the data so they could give the farmers indications of the total surface area or the areas where there would be food available for the livestock. So they were able to measure the biomass and give that out to the farmers. So these are the kind of changes, these are the things that they weren't able to do before Digital Earth Australia came along. And so that's really a capacity development activity. So this kind of co-design and co-production of activities with a mixture of the public and the private sector. I'm not going to go through each of the bullet points, but really what they were trying to do is get the streamline all of their activities by using Digital Earth Australia as a platform for doing that. So then they went to, on the second part of it, when they wanted to engage the industry, they went out for an industry consultation. And they talked a lot about what are the barriers to people actually using the Earth observation data and information, how could they work with Digital Earth Australia, and what's the value for the private sector. And then you can see the outcomes on the other side, where it's really about this business generation and growth. So this is something that's being ongoing. They had the consultation progress, and they've now developed, I guess, like a test bed. They had a number of grants, $50,000 grants that they've given out, and that's just gone live. So this is really starting to engage the whole of the private sector as well as the public sector in what they're doing. And so they've created a Digital Earth Australia industry strategy. And I'd encourage you to read it. I mean, it's very well written and it's quite straightforward. But really, it's about bringing a mix of education and industry together with the science, with the Earth observations and the work that's been done. So the Digital Earth Australia Labs is really the kind of the front end, the fast moving, the kind of software innovation and development arena. And this is something that is feeding back ideas and benefits and use cases from Digital Earth Australia. So what underpins all of that is this open data cube, the concept of being able to develop these open algorithms and share them across the community. So it's an open source community. People will put their algorithms in GitHub. You can go in, you can look, you can edit, you can share. And this Open Data Cube activity has been supported through something called the Committee on Earth Observation Satellites, particularly through NASA. And it started with a handful. It started with Australia and a handful of countries: Colombia, Switzerland, Vietnam, and now there's close to 50 countries who are now working on the Open Data Cube. And the Open Data Cube underpins Digital Earth Africa. So Digital Earth Africa came out of a number of discussions with Australia and the Group on Earth Observations, where I'm working. So I'm at the Secretariat for the Group on Earth Observations based in Geneva. So we wanted to take an approach that had been used for Australia, the size of a continent, to another continent within the global GEO framework. And I'll cover that at the end for those who don't know about GEO. But you can see here, we got money from the Australian government to start it and from the Helmsley Foundation. And these are the partners who've been involved. So we brought in the World Economic Forum because we wanted to raise this at the most senior political levels in government so that ministers understand the value of Earth observations. And that's quite a shift in terms of the scientific community and Earth observations. So at this point, I'll hand over to Aditya, and I'll let him talk about Digital Earth Africa.
Great. Thanks, Stephen. So I wanted to start with just basically pointing out that satellites have been in space for decades now. And these satellites have been collecting lots of data that covers every pixel on the planet. And these data have often not been as accessible as they needed to be. It's been costly to be able to access that before open data policies were in place. So the usage that you had from this abundant source of data was limited, and that's something that with the current cloud technology platforms that are available, with the decreased costs in data storage, that's something that that barrier is something that we're able to get over now, and because of these technologies that are in place, be able to really accelerate how these data are being applied. So I'm going to show a few examples, and then I'm going to kind of go into the story about how the work that was done in Australia led to the Africa Regional Data Cube, which then led to Digital Earth Africa. So these are some examples coming from Australia. This is doing an NDVI analysis, which is essentially looking at the health of vegetation. And you see a little black box there, which is indicating this graph below that in terms of the overall health of that vegetation. So green is good, yellow is dry, and red is basically barren soil. And so what this shows is that around the year 2005, the farmer who owns that particular plot made a decision to change the crop so that then thereafter you were getting much more healthy vegetation year after year. And so again, like this data already existed for that particular farm for the last 30 years. And by being able to put this data into a data cube format that makes the data analysis ready, and you're able to do the analysis over a time series, then you're able to sort of understand what the patterns look like, and you have a visual representation of whether that particular decision was good or not. In this example, this is looking at a lake in Canberra, and it's basically measuring total sediment load that's going into that particular lake. Again, you have about the same level of time series that you're being shown in that graph. Blue indicates better water quality, red indicates worse water quality. And in this particular case, the city of Canberra made a policy decision that reduced the overall sediment load going into that lake. Now you have a visual representation that's giving you direct evidence on whether that particular policy was actually making an impact or not. And obviously by this graph, it's showing that that was a good decision. Now, I'm going to shift over to some of the work that's going on in Africa, and then also kind of talk about how some of the algorithms that were developed in Australia are also then applicable in Africa. So this is looking at the water observations from space algorithm that Stephen was mentioning. And I'm going to work you through the workflow really quickly. So essentially, this is taking that same algorithm and applying it in Tanzania. So you're basically setting up your project area, you're importing the data, you're masking out clouds. This is all kind of an automated process within the infrastructure itself. Through the WAFS analysis, it's then identifying water bodies and then basically vectorizing those water bodies. And then it's basically computing what does the coverage of water look like at each time step. So using that kind of a flow, they were able to zoom into this particular lake and do that same level of analysis so that they're able to understand the fluctuations in total water coverage across that water body. And what they realized is that if you can imagine the different depths of water and what that means for the overall coverage of that lake, that then also gives you an indication of what the contours for that particular lake look like. And I'm not sure if this is going to work. Let's see. Nope, it's not. Let me go back. So if this worked, this would be a 3D visualization, and that map would be spinning around, and it would be showing you at each time step how the depth of that water is basically changing over time. And so now you have an indication of what the overall hydrography of that particular lake looks like, what the volume of that particular lake is like over time. And one of the things that we were discussing in one of the stakeholder meetings that we were having in Africa when we were showing this is one of the women in that meeting said, oh, like if we had this in some kind of a mobile application, we would be able to make better decisions at the village level about which water bodies that we're walking out to be able to collect fresh water. And so by having these kind of foundational data, the idea is then that you're able to take those data and create these different types of applications that are going to be able to have real impact on the ground. That's where we want to be able to get to. In Ghana, in Ghana and other countries, but Ghana in particular in relation to this particular example, looking at illegal mining was a high priority for them. There's huge impacts on overall water quality and deforestation that takes place as a result. And so Stephen mentioned the Committee on Earth Observation Satellites. There's a particular person within that team, Brian Killow, who's been doing a lot of work in relation to the Africa Regional Data Cube. And so they were then able to work with stakeholders and government agencies within Ghana to get training data for developing a new algorithm that would then look at where illegal mining might be taking place. And because that is a consistent issue across other countries, by going through that particular process, especially when it applies to the validation that's needed, then you can fine-tune that algorithm and apply it in other countries. Based on also some of the work that Brian is doing, he's working within these 5 countries, which is Ghana, Senegal, Sierra Leone, Tanzania, and Kenya, to come up with different types of applications on how a data cube type of an approach can help scale how some of these analyses are done. So this is looking at urban growth in Ghana. One of our objectives in terms of how Digital Earth Africa will be able to support regional and global initiatives like the Sustainable Development Goals or Africa 2063, Agenda 2063 in Africa, is that these data, the outcomes of these data are going to be able to support the different indicators in the broader Sustainable Development Agenda. In SDG 6.6.1, which is something that the UN Environment Programme is also working on, what we're trying to do is take these types of algorithms and put it into these technologies so that then it can be scaled across different countries. Countries can pick it up, be able to run that analysis, have the underlying data, and then be able to take care of some of the indicators that they need to measure towards that particular agenda. Did you want to say anything more about that?
Yeah, I mean, so we're working a lot with UN Environment, with NASA, with Google Earth Engine. We're working with a number of different organizations, the Joint Research Centre of the European Commission. And we're taking the approach is that as we're developing the methodologies for these different indicators, we're making these publicly and freely available. So for example, for SDG 11, there was work done that Aditya was also involved in for urban areas. So looking at population growth and looking at spatial extent and land use in the same area and bringing the two things together. So there was a pilot project that was done. There was a 50-page report that was produced, and it talked about what they did for the cloud cover, what they did for the SDMX, for the standards, for the statistical standards, and all of the approaches that they've done for that. So for everything we're working on around each of the SDGs or each of the indicators, we're trying to capture the methodology, we're trying to share the methods, the approaches, the algorithms, so that it's reproducible and reusable.
And there's a whole process that you have to go through in terms of being able to validate that particular methodology. So it goes from like a tier 3 indicator to a tier 1, which essentially means that there's an approved methodology and the underlying data for it. And so that's what some of these processes are going through with a range of stakeholders to kind of prove that this actually works at a country level. So here you have more on water quality for SDG 6.3.2. And so, I guess I should have probably put a couple of slides before this. So I used to be at this organization called the Global Partnership for Sustainable Development Data, which was, it might actually be up here. Yes. Which was really, so what we were doing within the Global Partnership is working with countries and being able to help national statistical offices and other line ministries develop a multi-stakeholder type of an approach so that governments are also working with private sector and civil society and be able to understand all the different types of options that there are where different data sources and technologies can really help the Sustainable Development Agenda, the National Development Priorities, and things related to the Sustainable Development Goals. And so the idea was, where is the demand at the country level, and how do we work with partners and different types of solutions in order to meet that demand? And consistently with the 5 countries within Africa that we were working with at the time, there was many issues related to environment, agriculture, food security, illegal mining, coastal resilience, deforestation, a lot of the problems that can, where Earth observation data can really help solve. And at the same time, there was these conversations that were going on between Geoscience Australia, Colombia, another country that I was working with at the time, also had a data cube. And we were really trying, and there was a big international effort to bring the national statistical community and the geospatial community together in the context of the Sustainable Development Goals and how geospatial data could help support that. So understanding that demand, the Africa Regional Data Cube was launched in partnership with GEO and the Committee on Earth Observation Satellites. Amazon was able to give us a grant that really provided the cloud infrastructure that was needed for that program. And I guess one thing that I probably haven't mentioned yet is that being able to have all of this on the cloud is something that's really able to scale how these data become more accessible and how we're able to get more users engaged around that data. So with open data cubes, so the Open Data Cube was essentially, it was developed at Geoscience Australia, and once they kind of understood how this could be applied in other countries, organizations like the Committee on Earth Observation Satellites then picked it up and helped scale how it gets adopted in other countries. So you're able to take Earth observation data, and about 80% of the time that you spend working with satellite data is often used on all the pre-processing work that's needed before you can actually get to the analysis of it. And so what this is trying to do is take that burden away and put that data into an analysis-ready format across a stack of time series data, such that you're able to then make these algorithms, you're able to apply the algorithms to it and be able to get better information and data that's ready for products and decisions. It's in the context of Digital Earth Africa and the Africa Regional Data Cube, it's going to be free and open. Before data like Landsat was openly accessible, it used to cost something like $1,000 a scene in order to do that. And in the case of Geoscience Australia, the work that they were doing to operationalize how an open data cube could be applied in Australia, it took them 300,000 scenes to do that, which would have cost them $300 million just to get the data that they needed.
And I'll just add on that point. This morning I joined the National Geospatial Advisory Committee, the NGAC, which is lots of senior government officials from the US, and they're going to submit findings of work they've done to put the case that Landsat remains free and open. So they're going to deliver that report tomorrow. So, I mean, it's kind of obvious to anyone who's been involved with Landsat, but that's going to come out tomorrow. And I think that's important because, you know, this is Australia, we're talking about Africa, the next one's Digital Earth Latin America, we've got Digital Earth Pacific. So this really is a global public good that's being done here by Landsat and by Copernicus and Sentinel. So I just want to highlight that.
That's good news. So probably in about May or June of last year, we started the phase one approach for Digital Earth Africa, which was essentially building out the business case. There was the Africa Regional Data Cube already existed, and there was work that was being done to align how that could be applied to challenges within those countries and the lessons learned coming out of that. But now what we wanted to do, knowing even when we were launching the Africa Regional Data Cube, which the Global Partnership and CEOS continued to work with, that there was more demand across the continent for that same type of an approach for all the other 50 countries that there are in Africa. And so with Geoscience Australia, and a number of other partners, we started some work last year to really understand what the landscape would look like. Part of kind of our success, part of what needs to be a successful approach for Digital Earth Africa is to be able to leverage the expertise and capacity that already exists within Africa and other institutions and programs that are trying to do something similar. So we were working with a range of stakeholders, understanding the landscape, how do we get political buy-in, what are the institutional arrangements, what are some of the technical requirements, what are the priorities for different use cases and so on, that then kind of framed the approach for Digital Earth Africa, which has now also led to a funded program thanks to the Australian government and the Helmsley Charitable Trust. There's about 18 million that has now been raised for Digital Earth Africa. So through Digital Earth Africa, we're now working towards an operational data cube. So what that essentially means is that you will have routine, reliable data that's going to be based on specific needs and priorities that are going to be aligned to like business cases that are happening at the country level, so that as you get new satellite data, those data products for the whole continent are being updated. And those are going to be decision-ready products, meaning that there's algorithms tied to the data with applications and web services built on top of that. It's going to be automated and run for every pixel. And this is going to be an institutionalized program within Africa. So we're working with the UN Economic Commission for Africa as the institutional host, and it's going to be staffed up to 20 to 30 people within the next 3 years. It's going to be multilateral, meaning there's a number of organizations that are going to be involved. We're working on the governance structure that will help form that. And again, like back to the point that there's a number of institutions and programs, we really have to kind of think about interoperability in the sense that we want to align with other institutions and initiatives and platforms so that what we're hoping to get to is something that is sharing data and algorithms across those institutions and programs. So the technical roadmap, which is something that we're working on, but this is something that we're going to have to do a lot more country engagement on to really understand what the priorities are at the country level. That's going to help inform what that roadmap then becomes. It's going to be an agile process, meaning that we're going to be iterative and we're going to be working with countries at different levels in order to build what that roadmap is going to look like. And this is all working towards analysis-ready data. We're looking at open architecture, where we're going to be using the stack format and looking at geotiffs, working with OGC type of standards, and being able to work on interoperability in the sense that through Digital Earth Africa, you're able to connect up with other types of GIS systems. Anything you want to say on this one?
Yeah, so irrespective of the country engagement, every country in Africa will have access to the data. So whether they engage at this level immediately or not, they'll have access to, for example, water observations from space, the first product that comes out. Some of the ways that it will be made available will be, for example, Esri has an Africa Geo portal. So Esri's already come to us and said, we're willing to give, for 5 years, 10 years, support for this. So that will be one way for countries to access the data. So I think one of the things I'll touch on at the end is we already have a network of countries that have been working with GEO for a decade. There's almost 30 countries there. And AfriGeo is that network, and AfriGeo is now going to be led by the Regional Centre for Mapping and Resource Development in Kenya, and they have another 20 countries, and not all of them are in AfriGeo. So we're getting close to 40 countries in Africa who are already working with us on Earth observation at some level. So we're already, we're not just pushing this out and sort of saying, hey, just use this new thing. This is working with a lot of, I think it's what Aditya is talking about the stakeholder engagement, and it being an iterative process. We're working very collaboratively with the countries to do this. And Kenya, Ghana, South Africa have been on the steering committee with us to guide us through a lot of these processes.
And so right now with Digital Earth Africa, it's still early days. We're very much in the phase where we're establishing the program. So that includes establishing the governance framework for it. That governance framework is stacked with institutions that are based in Africa, both at kind of the political institutional level to build the political buy-in that's needed for the program, and then also at the technical levels to ensure that institutions that are working already with countries on things related to geospatial, Earth observation, national statistics, and so on, that they're also then part of the technical advisory committee so that we can align programs as best as possible. We're starting later, well, I guess starting next month, we're going to really start pushing the whole country engagement process. So in August, there's an organization in Nairobi that is now also taking on this program called AfroGeo, which is essentially like how GEO gets implemented within Africa. They're holding their international conference in August, so we're going to do, that'll be kind of our first big sort of country engagement event in Africa on Digital Earth Africa itself. And then going through the technical implementation. So we're working with a number of partners with USGS on essentially how we're able to get all the data together for Africa and into an analytically ready format so that we're able to showcase something by the GEO plenary in November of this year. So I'm not going to talk to this slide. I'm going to move on from that one. And I'll talk about just really quickly like the 3-year vision that we're thinking about. And whether it's 3 years or it's a little bit longer, what this is actually talking to is like what does maturity look like for us for this particular program? And so right now we're basically setting up the foundation. So that's a lot of planning, a lot of strategy, a lot of partnerships, a lot of institutional arrangements. But you have to get some early wins. So the infrastructure has to be in place. And we have to build a process that will get us to our first continental-wide data product, which will likely be the water observations from space, which we're hoping to get to do all of that by the end of this year. Now that there's an infrastructure and some data in place, we have to then prioritize what do the next data products look like, which is essentially where the technical roadmap comes into play. But we also have to start building up the capacity and the uptake at the country level in terms of how users across sectors within countries are able to work with Digital Earth Africa directly in terms of how do they work with an open data cube. But then also, as data products are getting created from Digital Earth Africa, what does that actually mean for policy, for decisions, for action at the country level, and how do we support that process? Moving forward, like any open data infrastructure, we want to be able to inspire innovation, entrepreneurship, jobs, applications that are getting built that really go down to the ground level. And so we really want to create an ecosystem around this infrastructure so that we're bringing in all those different sectors, and we're really trying to identify what are the specific applications that we can build and be able to leverage the innovation space that already exists in Africa to build the applications. And then essentially what you're getting at that point is the data is being used and there's applications that are being built without any support from staff within Digital Earth Africa. It's creating the ecosystem itself. So, oh wait, this is back to you now.
Okay. I'm not quite sure why that slide's in there. You've all just sat through an entire presentation on Earth observations, and now it's like, Earth observations? So that's wrong. So GEO works. So I could sit up here and I could talk about another 104 countries that are members of GEO. So Australia is just one of our members. So that's important to understand that we have this global network, and it's all about the value and usefulness of Earth observations for research, policy, and decision making. That's what we're trying to do. So we're working across the world. We're working in agriculture, biodiversity, climate, disasters, energy, fresh water, land use, land change, oceans, anything you can think of that's really related to environmental monitoring, reporting. That's where GEO is working. 73 work program activities. So Digital Earth Africa is one of those 73. So that gives you a size of the scale of the activities that are going on in GEO. And most people don't know that. Most people think from the outside it's like an old boys club. So we're trying to change the perception a little bit and actually explain what we're doing. There are elements of the work program that are much smaller, and actually there are elements of the program that are much bigger. So some of the activities are really global. They've been going on for a while. If I take one example, GeoGLAM, the Global Agricultural Monitoring, the G20 in 2011, the G20 Ministers of Agriculture were looking for a place to develop global crop monitoring. So they came to GEO, they asked to create a framework, and so we've been doing that since then. So there's now crop monitors for over 100 countries, and this is actually being used in Uganda about 18 months ago. They were able to predict drought through the early warning system of the crop monitor and move people from 35,000 households. So that was 150,000 people who were moved because they could forecast there was going to be a drought. So they triggered the disaster risk financing from the World Bank to enable that. So that's impact. So we're not just doing this for, to get the nice pretty pictures. We're actually able to make some real strategic and potentially life-saving decisions on the ground. So if you want to learn more about what we're doing with the, we made an announcement yesterday. We asked Amazon for $1.5 million, which they kindly said yes to. And we've given out a bunch of cloud credits to just under 20 countries, developing countries. And they're doing a whole range of stuff from tsunami early warning systems to land use, land change, to deforestation, reforestation, afforestation. So there's many different things that are benefiting from the cloud credits program that we have with Amazon. So you can see it there. And then just finally, to end on an Australian theme, Every year we have a plenary where all the countries come together with all of our partners and participating organisations. So you're all very welcome to join us in Australia. This year is a special year because we have a ministerial summit. So that means we're going to have ministers coming from around the world. And the theme this year is return on investment. So what's the economic imperative of Earth observations? I.e., why would you invest in Earth observations? What do you get back? So with 21 seconds, just to make us perfect timing, we have 10 minutes left for questions. It would really help us if you could say who you are, like where you're from, just so we can get context for that. There is a mic up there. I think you have to walk all the way back again.
I'm Julia Beach, and I'm at College Board, totally unrelated to this topic. I work with web analytics. But I actually used to live in Africa, so it was very exciting for that. But my question was about, since it's cloud data and you're working with these countries, is network pulling the data down? Is that, talk about that. I would just imagine that would be harder even in rural areas for farmers. That might be hard for them to use this kind of data.
Yeah, I mean, that's a great question. It's one that often comes up. I think so with the Africa Regional Data Cube, which has sort of the bandwidth variability of, let's say, like Sierra Leone to Kenya, there hasn't been too many problems in terms of how the data cube within Amazon has been able to be used. And the reason for that is because the data and the analysis is obviously sitting in the cloud. And basically what you need to be able to do is push the algorithm, right? And for that bit, you don't need a whole lot of bandwidth to do that. So as soon as you send the algorithm, it's running elsewhere. And even if the power goes out, as long as it didn't go out right when you were pushing the algorithm, then you're fine. But then you can just come back to it.
Any other questions? Could you just use the mic? It's recording, yeah, you need to.
Hi, I'm Zakia. I'm from IT Strat. We're a company here in Tyson's Corner. This is too tall for me. What country would you say had the most drastic change from your product?
Well, I mean, I think that there's probably like a broader question there in terms of like how Earth observation data is being applied in the different countries, whether it's a data cube or not. And you probably have good insights on that. But I'll just say in the context of the work that's being done with the Africa Regional Data Cube, I think all of the countries are making really positive progress, and they're all addressing different types of issues. So like in Sierra Leone, one of the big issues there is disaster risk, especially from landslides. And so they're running analyses related to that. In Ghana, there's been a really interesting effort there on the illegal mining issue being one part of that, but they're also doing a lot of work now on related to climate change and agriculture that they're making lots of progress towards. What we're trying to do as part of some of the work that's happening with GEO is capture all the impact that's coming from the Africa Regional Data Cube, and the Global Partnership for Sustainable Development Data is helping us do that.
Yeah, I mean, if you look at what happened in South Africa over the last couple of years with drought, Morocco has issues, Kenya's in the middle of a really bad situation. Those are where, and this is why we're really trying to get the ministerial buy-in so they understand these upfront investments in Earth observations can help them make those longer-term decisions. So it's those big topics around food, agriculture, land use, the interconnectivity, how all of these systems are interoperate and how the science is all related. So you need to understand water, to understand food production, to understand land use. All of these things are integrated. But it's really hard. The science is really hard. And being able to translate that from the science and the technology into impact and into an economic position is really what we're trying to do. That's where we're going. So it's not one country per se. It's we're trying to do this for continents and help many, many different countries to do it because many of the challenges they're facing are similar. We got 5 minutes left if there's another quick question. Could you use the microphone, please?
My name is Isaac Tabe, Oracle background. Actually, I'm very fascinated in this area. I'm originally from Africa and precisely from Cameroon. Actually, when I hear about this topic, it's of more interest to me because I've worked in Africa, in most of the region, Cameroon and in Egypt. And my question is, in Africa, we have this issue of infrastructure in place, and how is this digitalization of Africa going to help put in place of infrastructure, given the fact that government policies differ across Africa, West, East, and the South? So how do we look to address this issue of policies compliance?
Thank you. I'll let Aditya answer that.
Thanks, Stephen. No, great question. So I think your question is both in terms of how Earth observations is going to support some of the infrastructure issues across Africa, and then what that means for how you kind of align policies within the different regions, right? So one part of the answer to that, and I'll try to summarize, because it's related to the governance, essentially, for Digital Earth Africa. And so one thing that we're going to be doing within the governing structure of it is rely on some of the regional economic communities that cover 8 of the sub-regions across Africa, and then have other continental-wide partners like the UN Economic Commission, the Africa Union, Africa Development Bank, all be part of that governing structure, because that's where the policies are going to happen. And that's also where you're able to sort of understand the needs and the challenges and be able to kind of promote the uptake at the country level for those countries that belong in each economic commission, right, or community. So that's part of it, and it's also the partnerships that we're going to be creating with other institutions that are doing a lot of that work. Infrastructure and looking at urban environments is something that's going to be really important from Earth observation data. It's also data that you want to be able to try to get to some higher resolutions on also. And so while the first iteration of Digital Earth Africa is going to be on Landsat data, which is at the 30-meter resolution, that allows you to understand more about what the change is looking like across time within an urban environment. So you can understand things like urban sprawl and change. You want to be able to get to more like 10-meter resolution when you're really looking at what some of the infrastructure issues are at the city or urban level. And so that's where we're going to be working with the European Commission to try and get some of the Sentinel data as part of Digital Earth Africa.
And the private sector.
And the private sector. And so there's another EU funded, another European funded program for Africa called GEMAS, which is around environmental monitoring. And so we're working with GEMAS on creating a partnership that will help accelerate how that Sentinel data can become available as part of Digital Earth Africa.
So we have 2 minutes left, so I'd like to wrap up. Thank you for coming. Thank you for attending. And if you have questions, you have our Twitter accounts, our LinkedIn profiles. And if you want to do it the old-fashioned way, you can come up and talk to us after the event. So anything else you want to say?
No, thank you for coming. Is this the last session of the day? I don't know. Okay, so thank you for sticking around for the last session of the day. Okay.